issues with air. So you've talked about what air is and how the atmosphere works. You did that with Mr. Holmes. We did a lab on measuring carbon dioxide. So we kind of flip-flop things a little bit, but my mentor was here and he wanted to see us do a lab. So that's why we move things around. So now we're going back to the issues with air. So basically the issues, the pollution issues in the atmosphere and why they're issues. Okay, so pollution, the kinds of air pollution. So there's air pollution, which is the release of any damaging materials into the atmosphere. Trell, do you need a pencil?
Yeah,
Kyler, do you need a pencil?
that's Calvin. You want one, Kyler?
Sorry, Calvin, do you need a pencil?
Kyler, do you want a pencil?
Okay, so emissions are tiny particles from either smoke or soot, or gases, so sulfuric dioxide or carbon monoxide, that are released into the air and cause issue. There's two ways that these emissions get into the atmosphere. Okay, so there's natural processes, such as winds blowing dust up, volcanoes erupting, forest fires. Okay, so all those things are natural processes. Then there are your human sources. So most of the human source air pollution comes from vehicles. Comes from our use of fossil fuel. Okay, when you burn fossil fuel, guys, when you burn fossil fuels, your products are always going to be carbon monoxide and water. So that carbon monoxide is released into the atmosphere and it causes some issue. So we're going to talk about climate change a little bit, but just from looking at this slide and knowing that climate change is caused when gases or particles are added to the atmosphere, do you think climate change could be a natural process?
Yeah.
Why?
Why not?
Well, I want you to answer specifically with some of the things that are on this slide.
What was the question again?
Okay, so do you think that climate change, which is a process that's caused by the addition of carbon monoxide and other gases or particles being added to the atmosphere, do you think it could be a natural process?
Climate change?
Yes.
Yep.
Okay, and yes is the right answer, but why?
There's pollution.
Okay, natural pollution. Where does natural pollution come from?
Volcanoes.
Yeah. So the volcanoes erupt. A volcano can erupt and release the sulfuric dioxide into the atmosphere. When wood burns, it also creates carbon monoxide and water. Okay, so those things can naturally drive climate change, right? And if you look back in history, our climate has always changed, right? So there have been times when Saskatchewan was in a tropical area, right? There have been times when we've been under, 20 stories of ice. So climate is always shifting. And then the human sources may make that climate change go faster because we're increasing that amount of carbon monoxide quickly. Okay, were you done, Calvin? Okay. All right, so how air pollution affects your health. Okay, so it can affect your respiratory system, so your breathing. Dust particles irritate some people's air passages and lungs. Okay, that's why you'll see sometimes people in Japan walking around with masks on because there's so much smog, there's so many particles in the air that if they breathe it, their lungs hurt. If people are exposed over and over, they may develop asthma, bronchitis, or emphysema. And emphysema is usually attributed to being a smoker, and it just means that your lungs don't work very well anymore. Okay, and then there are the effects of carbon monoxide. So on your blood cell, there's one spot on each blood cell where an oxygen molecule can bind. And when that oxygen molecule binds to your red blood cell, it's transported through your body and released somewhere else where a cell somewhere else in your body needs oxygen. Okay? Carbon monoxide can bind to that same spot, but it will not be released. Okay, so there's no place for the carbon monoxide to be released from that cell. So that interferes with where that oxygen, how much oxygen your blood can carry, right? Because if half your blood cells are covered in carbon monoxide, that means half your blood cells are not able to deliver oxygen to your body. So that can cause headaches, tiredness, and nausea. Over time, this can damage your heart muscle as well because your heart is having to beat harder and harder and harder to get the blood enough oxygen to your body. It's also being damaged by the carbon monoxide. So the carbon monoxide isn't helping it work. Has anyone ever heard of anyone dying from carbon monoxide poisoning?
No.
Does anyone have a CO detector in their house?
Oh, fuck.
Yeah, I do.
Okay, sometimes your smoke alarm will be a CO detector as well. So basically it's just detecting to see if there's a high concentration of CO in your house. And if there is, you could die. Okay, because what would you think? What would be the first thing you would think if you had a headache, if you were tired, and if you were nauseous?
You're sick.
You were sick. What do you do when you're sick?
Go to bed.
Go to bed. So if you're going to go to bed because you have a headache, you're feeling tired, and you're nauseous, but the CO levels in your house are continuously rising, what do you think is going to happen?
You're going to die in your sleep.
You're going to die, right? Because the oxygen isn't reaching your body's cells. Okay, and people have died that way. Okay, and then cancer, trace amounts of air pollution may contribute to cancer. So there are chemicals that are called carcinogens, and a carcinogen is literally a cancer-causing agent. So if carcinogens have been released by plants, not like plants like flowers, but like industrial plants, they're in the atmosphere, you're breathing them in, they could cause cancer. Okay? All right. Smog. So there are two kinds of smog. There's your industrial smog, which happens when the sulfur is released by industry into the atmosphere. That combined with water as the water passes through it. And as that happens, it creates acid rain. So when sulfur and water meet, you get sulfur dioxide, and sulfur dioxide is an acid. Okay, or you can have photochemical smog. So photochemical smog needs light, and it forms when the light reacts with certain types of air pollution. The atmospheric ozone is the most abundant pollutant in photochemical smog. Okay, so we think ozone. Ozone's great. Ozone layer saves us from the sun, right? But if there's ozone in the atmosphere, it's not great. It's awesome if it's in that layer, but if it's in the atmosphere, that's not good. Okay, so what can happen is the carbon monoxide goes into the atmosphere. It rips a CO2 or an O2 apart because it wants to be CO2. So then there's this one little O floating around, okay, and he wants to be bound to someone else. So he binds to an O2, and then you get O3. An O3, so 3 particles of oxygen combined together, is ozone. Okay, and ozone can damage living tissues. Okay, so it's not great. So we need to make sure that we're not. Okay. All right. Good. All right, temperature inversion. Okay, so there's nothing you have to write down for this one. Okay, so recall the troposphere. Air temperature usually decreases as altitude increases. So as you go further from the Earth, the temperature decreases. Earth's surface warms the air in the lower altitude. Okay, so the Earth is warmed by the sun, right? So our atmosphere is warmed and the Earth is warmed and things bounce around. Okay, and then the energy that's bouncing around also warms the air closest to the Earth. Since warm air rises, right, you've heard that before, that's why hot air balloons work. Warm air rises, any pollutants that are caught in that warm air rise with the warm air into the colder areas. And that leaves pollutants in that higher altitude. Okay? So this process does remove pollutants from the lower altitudes and helps them disperse. Okay, so it goes up and it kind of disperses around. The situation is different, however, when a temperature inversion occurs. A temperature inversion is the condition in the troposphere in which a layer of cooler air is located beneath a layer of warmer air. Since the cold air is a greater density than the warm air, the air from the Earth's surface does not rise and mix with the air higher up. Therefore, temperature inversions can keep air pollutants, including those found in smog, from going away. Okay, and that's usually why. Has anyone seen a picture of a big city? It looks like they have like a yellow bubble on top of the city. Has anyone ever seen that?
Yeah.
So that's what's causing that. That bubble of smog is stuck there because there's nowhere for it to go. All right, acid rain. So some of you did your first research assignment, your water research assignment on acid rain. But acid rain is also caused by issues in the atmosphere. Okay, Calvin, I need you to take your phone to the office, please. Okay, so that's the choice you make. I'm going to give you an option to make a better one. If you're not going to make a better choice, we'll go talk in the hall. So, when pollutants combine with water and oxygen, they create acid. We kind of talked about that already, right? So, sulfur mixes with the water, creates sulfur dioxide, which is an acid. And that can fall in any type of precipitation. So, it's not just acid rain. It could be acid snow, it could be acid sleet. So many sources of sulfur dioxide and nitrogen dioxide are from burning fossil fuels. So I said your products, when you burn fossil fuels, are always carbon monoxide and water. But if there's additives or if there's other things that were pulled up from the earth in that fossil fuel, those get burnt and sent into the atmosphere. So the effects of acid rain include harm to the ecosystem and to man-made structures. If the pH in lakes falls too low, fish can't survive. Okay, just think of trying to live in a vat of acid. Kind of suck. And then acid can also erode away rocks. It'll erode away the rocks, it'll erode away a lot of things. Okay? Alright, so how have we worked to reduce air pollutants? So, motor vehicles. Things have changed in motor vehicles. Things like the catalytic converter is a device that reduces the amount of air pollutants in emissions. So we've made cleaner gasoline. Gas used to contain lead. Okay, have you ever wondered why every single gas pump you go says unleaded?
Yeah.
Have you ever seen that? Unleaded? So that just means that all gas that's created now doesn't contain lead. And what would happen is the lead really didn't do anything for your vehicle, but when you're, okay, Rylan, cut it out. Okay?
Or Mr. Will.
Thank you. So the lead didn't really do anything for your vehicle, but as the gasoline was burnt, the lead would be emitted into the atmosphere. Okay, so it would go into the atmosphere and it would usually fall and contaminate the ground. And then rain would fall, would wash the lead away, so then the lead would end up in streams and rivers. Okay? Lead has been outlawed in gasoline since 1973. Okay, and then the third way that people have started to reduce air pollution. So industries and power plants have added scrubbers to their plants to remove or change emissions chemically before they leave the factory. So if they can change them to a less harsh chemical, that's always better. Okay, so ozone. Has anyone ever heard that there's a hole in the ozone? There's a hole in our ozone layer. There's a big one over Antarctica, I believe. So the hole was first noticed in the 20th century. Chlorofluorocarbons, or CFCs, because chlorofluorocarbons is hard to say, are chemicals that have been predicted to cause the depletion of the ozone layer. So they're found in refrigerators, so the stuff that runs around in the back of your refrigerator to cool things down, or in aerosol cans contain chlorofluorocarbons. And those react with the ozone. So in the atmosphere, they pull the 3 particles of oxygen apart and change it into just O2, okay? Which depletes, it gives us a little bit more oxygen, but we don't need a little bit more oxygen, right? We need that ozone layer. So the Montreal Protocol, many nations began to restrict the production of CFCs. Today, the production of CFCs has dropped 95% since the late 1980s. Evidence indicates that the ozone is beginning to recover. The levels of ozone have stabilized, and scientists believe that they will soon begin to increase to their former levels. So there are natural processes that will allow that to fix, to change. Okay? All right, the greenhouse effect. All right, so the greenhouse effect. Okay, Terrell, can I get you to sit down, please? Okay. Girls, you need to be copying down the notes, please. Okay.
Oh,
Okay. So,
not cold.
if the Earth did not have an atmosphere, Terrell, if the Earth did not have an atmosphere, most of the energy from the sun would be reflected back into space. Okay, and you talked about last class with Mr. Holmes how the atmosphere allowed energy to bounce up and down, right? If that atmosphere left, we would be cold. Okay? The greenhouse effect is a natural process in which certain gases in the atmosphere keep heat, or should be heat, near the Earth and prevent it from radiating into space. So the gases that do this are called greenhouse gases, and we need them. We really do need them. The major greenhouse gases are water vapor and carbon dioxide. So the term the greenhouse effect is misleading. Okay? Greenhouses are used for plants to hold heat in a place and prevent warm air from escaping. In contrast, greenhouse gases, gas molecules, in the atmosphere do not trap air or anything else. They absorb the heat and release it slowly. Okay, so it allows everything to kind of fluctuate and stay at the temperature that we need to live. Okay, so the causes of climate change.
Smoker's cough.
So, an increase in greenhouse gases. Right, we talked about how extra layers of gas are going to keep us warmer. Because the greenhouse gases in the atmosphere are the reason The Earth keeps warm, increasing the level of greenhouse gases, mainly the CO2, doesn't allow heat to radiate out from the Earth, creating a shift in the climate. Okay, so more CO2, less heat is leaving our atmosphere. So the burning of fossil fuels helps increase that amount of CO2. So we get fossil fuels, if you don't know, include oil, natural gas, and coal that we use for energy. Oil is broken down to this, like the stuff that you actually put in your car, and gasoline. And then natural gas is, if you have a natural gas furnace, that's what it burns. And a lot of our energy comes from plants that burn coal to make electricity. These fossil fuels, they're called fossil fuels because they were formed millions of years ago from the remains of living things. So our fossil fuels are literally dinosaurs. Okay, dinosaurs that have been trapped, other plants, vegetation, that kind of stuff. It's trapped under the earth, and over millions of years were turned into fossil fuels. And then there's the changes of land use, another cause for climate change. Land use changes, such as cutting of forests, have increased the amount of greenhouse gases. So you know that plants, including trees, take in carbon dioxide, and therefore the loss of forest contributes to the increase of carbon dioxide in the atmosphere. If there are fewer trees, it can take less carbon dioxide. So that carbon dioxide has to stay somewhere, and that's usually in the atmosphere. So, evidence of the Earth warming. When scientists talk about global climate change, they refer to many characteristics, such as temperature, rainfall, wind patterns, and storm frequency. The term global warming refers specifically to the increase in Earth's average surface temperature. Okay, so you'll hear both terms used, global warming, climate change. Global warming is only one little thing. Climate change is all of those different things together. Okay, so that means there were something like 15 named hurricanes that hit North America, or made landfall last year. Okay, that's a huge increase of the number of hurricanes that have hit land. So, rising temperatures. The Intergovernmental Panel on Climate Change notes that the average atmospheric temperature near the surface of the Earth has increased by 0.74 degrees Celsius between 1906 and 2005. Most of the increase occurring in the last few decades. And that might not sound like a lot, but if you think about it, what's the difference for ice between 0 degrees and 1 degree Celsius? It's no longer at its freezing point, so it's going to start melting. Right? So that 1 degree can change how much ice is in our ice fields. And it has, dramatically. It's changed that very drastically. The changes in precipitation. Changes in precipitation over 100 years have been complex. Some regions receiving more precipitation, while others are receiving less. Heavy rainstorms have increased in both dry and moist regions. Okay, so Saskatchewan, this year, we had so much rain. There's so many big dugouts and farmland that have been lost to big puddles, basically. Meanwhile, in some areas, their lakes and rivers are drying up because they're not getting enough precipitation. So there's also melting ice. We kind of talked about that already. Large glaciers, sheets of snow and ice coverings at the poles, and glacier shelves are breaking apart and melting. If you're interested in seeing that, it's kind of a dull documentary, but really pretty pictures. It's called Breaking Ice, I think it's called. It's on Netflix. And basically they set up cameras and they did a time lapse of how different ice places were changing. And the changes were fairly dramatic. And then rising sea levels. So both the warming of the seawater and the melting of the ice are contributing to rising sea levels. As water warms, okay, it expands just a little bit. Ice melts, adds more water. What happens if our sea levels rise? What do you think will happen?
Less land.
Less land, right? That water has to go somewhere. It's going to go up onto our coasts. Okay, everyone has that copy down? All right, so effects on ecosystems and organisms. So Science 10, you learned about ecosystems. So an ecosystem is an area of land, all of the plants, animals, plants, animals, insects, bacteria, protozoa, everything that lives in an area. So habitats have been shifting because climates are changing. So as an ecosystem on land becomes warmer, locations in which organisms live are changing. The habitats of some plants and animals have shifted to places where the climate is cooler. Right? A lot of plants and a lot of animals have a very small-ish window of where they can live successfully. Right? So those things are shifting, those areas are shifting. Changing migration times. Many species of birds migrate every year. Some birds are starting their spring migrations earlier. The change in temperatures probably sending signals to the birds to start their migration. So they're coming back earlier, which could be an issue, right? Because our winters are lasting longer, right? We had snow on the ground last year until the end of April, I think. So if the birds are coming back earlier, because where they are is warmer, they're going to be coming back to snow. And what does that mean for the birds? Why?
Too cold.
It might not be too cold because it was an okay temperature, but there was snow all over. What does snow cover?
No freaking food.
Exactly. The snow covers the ground. The ground is where they get their food. There also probably aren't many insects, so there's nothing for them to eat. And then, just what I was talking about, problems obtaining food. During the last few decades, temperature changes have been the greatest in the Arctic. Ice sheets are melting and sea ice is thinning. The sea ice melts earlier and freezes later, and it's become more difficult for animals like polar bears to hunt seals to feed on. There's a really super sad commercial on TV right now, Sarah McLachlan singing, and there's this polar bear, and she's swimming, and then they say she lost her cub. Okay, so things are happening. It's getting tough out there.
Struggle is real.
All right, that's all. So I have an assignment here for you to work on. 6 questions.